Hello, everybody. I will start my today another live coding session. So today is the question permutations. Okay, so giving an array nums of distinct integers, return all the possible permutations. We can return the answer in any order. Okay, so let me clarify my understanding first. So in this question, I'm giving an array nums, which is distinct integers. This is an integer array. And I will return all the possible permutations. So this should be the list of list of integer, which represent each permutation, and the list of them. This is what I should return. Okay. And as the constraint, something I should focus is, for 3, I can see each num is distinct integer. Or I should say unique. So I don't have something like 112. So in this case, I have to take care of it because this one and this one is the same. So I have to take care that I include these ones distinguished when I create the permutation. But in this case, I don't have to take care of that. Okay. Aside from that, also I'm wondering if there is at least one element in the given nums array, and I check it, and yes. So I can say there is at least one element in the nums array. Good. So that being said, let me start with seeing some examples. Let's say I have 1, 2, 3, and in this case, I should return something like this. So when I take 1 first, and 2 then, and 3, or I can choose 3 first and then 2, the remaining number, or as the first number, it's possible that I can choose 2, then I choose 1 first, then remaining 3, or I choose 2 and then 3 and remaining 1, or the same way, it can be 3 first, 1 next, and then remaining 2. Or 3 first, 2 next, and then remaining 1. Yeah. I think these are all the permutations I can create, so I returned this one. Good. Okay, so let me think of the algorithm. So I think the brute force approach is, what should I say? I do the recursion. Yeah. And each recursion, I pass the remaining numbers list and also the number I've chosen so far. And for each recursive function, I choose one next number and then call another recursion with one number added to the chosen numbers list and the chosen number removed. No. Yeah. Sorry, I mean, in the recursive function, I pass the chosen numbers, and every time I pick one number, then add it to the chosen nums list, and then call another recursive function. If all the numbers are chosen, I build the list and add it to the global variable, global list to be returned in the end. Yeah, but this takes much time, I guess. So the recursive function should be called n, the factorial of n, because this chosen nums variation should be the factorial of n. Yeah. And for each recursive function, it takes O(n) time because I have to traverse each, possible next number. So this takes this much. Okay. And also, I have to create chosen nums list in each recursive function. So this takes this much. Okay. But I think I use the backtracking instead. So the big difference is that I don't have to create a chosen numbers list again and again. Instead, in each recursive function, I append the new numbers to chosen nums list and then call the next function, recursive function, and keep going. And as the base case, if I've chosen every number in the given nums array, then I create the list. Actually, I have to copy the chosen nums list to a new array, then append it to the returned list, which is global. Yeah. And I continue it. Okay. So I think the time compress is actually the same because in the end, I do the recursive function, which is, the factorial of n. I mean, chosen nums, which is the argument of the recursive function, has the factorial of n variations. And for each, in the end, in the base case, I have to create the list, which takes n time. So in total, it should take n factorial times n. Okay. So that's the basic approach I can take. I think it's quite typical backtracking. So let me get started with implementation. So So the problem here is no okay, let me first implement it and maybe optimize more. So create permutation, and in the end I return save those permutations. So my task in the create permutation method is create a new permutation, and I append it to the permutations. So as a base case, if I've chosen all the numbers, then that's it. So I copy this self.numSolver and append it to the self.permutations. Okay. Then I return. Otherwise, I have to choose one number from the remaining ones. So if that number is not chosen yet, so I append it to the self.numSolver. Then I call the recursive function. Then after coming back, I have to roll back. this one. Yep, this is it. But the only thing I have to take care here is, this actually takes n squared time in lines 46 and 47. Because line 46 has n steps, and for this one, I'm traversing each number in self.num solver to check if num is included or not. So instead, one optimization I should make is I should have the set also. So this num solver set is a set of chosen self.num solver numbers, elements. In this way, I can check, in line 48, I can check if num is in this set, which takes some reason all one time now. And obviously, in the line 49, I also have to append this num to set 2. And also I have to revert this up to the recursive function call. Okay, this is it. Good. So space complexity, it will take, so num solver can be up to n. Permutations, I don't include it because this is a returned array. And also recursion stack, which should take all of n space because the max depth of the recursion should be n. Because every time a new element is added to the self.num solver, and it continues until there are n element in the rest num solver, it should be all of n. So in total, it should be all of n. Okay. Good. So let me walk through my code. I will go with a very simple case like this. So in this case, num solver begins with empty array. And num solver set, this is also an empty first. Yeah. Then permutations, this should be an empty list first. And I call the create permutation method. And in line 51, self.num solver is now empty, which is not equal to the ranks of the nums. So I go to line 55. So for each number, in this case, 1 only, when num is 1, this is not in the set. So I append this to the num solver and also to the set and call the recursive function. And inside of it, now self.num solver is equal to 1, which is equal to self.num rank. So I add this one, copy this one to the returned self.permutations. Good. And I return. So I come back to line 62 and I pop out self.num solver.pop. So this one is popped out. And also from set, one is removed. So it's completely cleared. Good. And that's the end of the recursion, for loop in line 57. I come back to line 49 and go to line 50 and return set of permutations, which is 1. Okay, so I passed this test case. Good. So maybe I will quickly check the case of 2, 1, 2. Because I've covered already all the lines, I will go for very quick. So num solver is added one first, and then what should I say? I should write it in this way. So when this is called first, one is chosen, then num solver and num solver set has one, then create permutation is called again. This time, one is already inside of it, and I have to choose two. This is the only option. Then I call create permutation again, and now 1, 2 is inside, so 1, 2 is added to the returned list. Okay. Then I come back, and then here I don't have any choice, but here I have the choice to choose 2. And again, I create permutation, and the only option is to choose 1. Then I call the recursive function again, and I add 2, 1 here. Yeah, and that's it. I come back, and I don't have any more choice because I've iterated both of 1 and 2. Yeah, so that's it. So 1, 2, and 2, 1, the rest of them should be returned as expected. Okay. So I also passed this test case. Nums is 1, 2. Okay, great. So I'm pretty confident in my code. So run execute. Accepted and accepted. Great. Okay, so let me quickly wrap up. So today I solved the question, permutations. This is quite a famous and typical backtracking question. So given the nums of the distinct integers, this is important. And I should return all the possible permutations. So in this question, I use the backtracking. And so I mean, in the every recursive function, number chosen is appended to the num solver list, and I keep going. And when num solver has all the numbers in the given nums list, it means that it's a base case. So which means that the permutation is created. So I copy it and then add it to the return list. So I keep doing it. And for the time of complexity optimization, not only the list of num solver, I also created the num solver set so that I can quickly check if the number is already included in the num solver list or not. Yeah, so that's the basically algorithm I chose. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.